Welcome back to another video here on the Unknown Code YouTube channel. Today we are taking a look at 167 to sum 2 input array is sorted. Now as you can see, this one is actually a medium problem, so it's a little bit harder, but I think this one's actually not that hard, especially compared to some of the other ones we've seen. It states given a one index array of integers called numbers. Now we are going to talk about this one indexed means a little bit later on when we get to some of the examples, so don't worry about that right now. That is already sorted in non-decreasing order. Find the two numbers such that they add up to a specific number called target. So basically it's going to be two sum once again. We're just trying to find two numbers that add up to the target. We're going to let these two numbers be numbers index 1 and numbers index 2, where 1 is less than or equal to index 1 and index 2 is less than or equal to numbers of length. So basically they want us to keep track of the indexes of the two numbers that we find here. Finally, what they want us to do is return the indices of the two numbers index 1 and 2 and add 1 to it as an integer array, index 1, index 2 of length 2. So this is what it means by it's saying index 1 array or one index array. The array itself that they give to us obviously isn't one index, but they want us to be able to add 1. That way it is basically one index. It's a little bit confusing. Once you get past that part, it's not too bad. And moving on, it says the tests are generated in such a way that there is exactly one solution. And you may not use the same element twice. So no matter what, we'll have one single solution, so no problems there. And then finally, your solution must use only constant extra space. This is lingo for saying that you need to do this basically in line. We can't make a new array, we can't sort it or anything like that. We have to actually do this as is. But I mean, already it's basically already sorted, so we shouldn't have to deal with that anyway. So, it is what it is. So let's go ahead and take a look at the couple of examples that they give us. They actually give us 3, so there's quite a bit. And then the constraints and kind of move on from there. So for the first example, we're going to be given an array numbers equal to 2, 7, 11, 15, and our target value is equal to 9. So the goal is to find two numbers or two indexes that are going to add up to 9. So obviously 2 plus 7 is equal to 9, so the index is 0 and 1. They want us to add 1 to those, so the output is going to be 1 and 2. All right, that's simple enough. Let's take a look at the next example. In the second example, we're given a numbers array equal to 2, 3, 4, and the target is going to be 6. So this one, we're obviously looking for something that's going to equal to 6. So in our case, it's going to be 2 and 4, which is equal to 0 and 2. And we need to add 1 to those. The output is going to be equal to 1, 3. Again, nothing too crazy. Let's take a look at the final example. Example number 3, we're given an array of -1 and 0. And the target is -1. Obviously, there's only 2 indexes here, so the output would just be 1 and 2, and that is as simple as that. So let's go ahead and take a look at the constraints to see if there's any information we can get and kind of move on from there. Like I said, they give us a whole bunch of constraints. The first one being 2 is less than or equal to numbers of length is less than or equal to 3 times 10 to the 4. So this is saying that the length of the numbers array is between 2 and 3000. So this one's pretty nice. It's always going to give us at least 2 indexes to look against. And there's nothing in here saying that the target value is not going to be there. So obviously if there's just 2 indexes, we can just return 1 and 2 like we saw in the example. And then the 3000, that means there's just not going to be that many numbers in general. So there's not going to be that big of an issue with time complexity or anything like that if you really needed to try to brute force it. The next constraint says -1000 is less than or equal to numbers of I is less than or equal to 1000. So this just means the values inside of numbers are between -1000 and 1000. So to us, these are basically just arbitrary numbers. We don't have to worry about anything here. Nothing too crazy. Now, something that is important is that numbers is sorted in a non-decreasing order. So this means that the largest numbers are going to come to the end, the smallest numbers are going to come to the beginning. And this is going to play a big role in our solution, which we'll talk about in a second. Then we have -1000 is less than or equal to target is less than or equal to 1000. So once again, this just means that the target value is between -1000 and 1000. So there's nothing too crazy going on there. And finally, we have the tests are generated such that there's exactly one solution. So again, this just says, hey, there's only going to be one given solution to this no matter what. So you have to get it exactly right. So again, nothing too crazy on that one. The most important thing here is going to be that they're already in non-decreasing order. So again, just to reiterate, the goal of this problem is to search for exactly 2 numbers in this array which add up to a target number. And then once we find those numbers, we need to remember the indexes we found them at and add 1 to make it one indexed. And then finally return them in the correct order in that new array. This problem is marked as medium, and I believe it's because the wording it's a little bit tricky. But once you know the trick to this problem, it's actually easier than the first 2 sum problem. The magic in this problem lies in the fact that the array is already sorted for us. So like I was saying before, This is going to be a big trick to this. And again, what it means by it's being sorted for us is that the smallest numbers are starting at 0 index and the largest numbers will end at the last index. There's actually a searching algorithm that works very well and quick on pre-sorted arrays called binary search. We can basically take the first number of the array, the number in the middle, and then determine whether or not the number is too large or too small. And then go ahead and slide those pointers in either direction, since we know the numbers on the left are smaller, the number on the right are larger. Let's go ahead and take a look at the pseudocode and the example walkthrough before hopping over to LeetCode. So for our pseudocode, we're going to go ahead and say let left pointer start at 0. We want to let right pointer start at array.length. Then we want to say while we haven't found the target, and then if the value at left plus right is greater than the target, and we want to check if the value at left plus middle is greater than target also. This means that we need to go ahead and shift the right to the middle index. Again, this works because we know that the numbers to the left are going to be a little bit smaller. So the right index is starting at the very end. The middle index is, of course, starting in the middle. So that means that we're going to set the right index a little bit smaller, or the right value a little bit smaller. Otherwise, we want to go ahead and say decrement right by 1. Then we also want to check the opposite. So we want to check if the value at left plus right is less than target. And if value at mid plus right is less than target. This means that that left index is going to be too small. We need to go ahead and set left index to mid. Otherwise, we'll just go ahead and increment left index by 1. Finally, after our loop, we'll go ahead and return a new array with left plus 1 and right plus 1. So it's as simple as that. We just need to basically keep track of the middle and then determine if we need to move left or right. So let's go ahead and take a look at our example. Fingers crossed I can get this one to fit on one page. For our example, once again, going to use numbers equal to 2, 7, 11, 15. And our target will be 9. So we're going to go ahead and start at I equals 0, iteration 0. Our left will be equal to 0. Our right is equal to 3. And our mid is equal to 2. So once again, all we did was set left to 0. And then right is the last one, and then middle is in the middle. Obviously, whenever you divide by 2, it's going to be integer division, so we went ahead and rounded up to 2. So that's our first little iteration here. So numbers of left will be equal to 2, and numbers of right is equal to 15, and numbers of mid is equal to 11. So our 2 plus 15 is obviously greater than target. That's the first check. Or otherwise, it's numbers of left plus numbers of right. So that's greater than 15. So now we want to go ahead and check to see if the numbers of left plus numbers of mid is greater than target. So that's 2 plus 11. This is obviously also greater than target. So again, we check to see if numbers of right plus numbers of mid was greater. So basically this means that we need to go ahead and shift right to mid, so right equal to mid. So I equal to 1, left is still equal to 0, but now right is going to be equal to 2, and now our mid is equal to 1. Once again, we've got our left here, our right is at 11, and then the middle is at 1 at this time. So now our numbers of left is still equal to 2. Our numbers of right is equal to 11. And our numbers of mid is equal to 7. So now we need to go ahead and check to see if the numbers of left plus numbers of right is greater than target, which it is, because that's 2 plus 11. So now we need to go ahead and check to see if numbers of right plus number of mid is greater, which it is technically not, but it's also technically equal to, but it's 2 plus 7, which is equal to target. So still, we want to go ahead and say right is equal to mid. And now finally, for I equal to 2, left is still equal to 0, right is equal to 1, mid is equal to 1. And now our numbers of left is equal to 2, and numbers of right is equal to 7. And now our 2 plus 7 is equal to target, so the loop exits. And we go ahead and return left plus 1 and right plus 1, which is also 1 plus 2, which is 1, 2, which we expected. All right, so we learned to have a little bit of room there, but we got all to fit. So this works all fine and dandy. Let's go ahead and hop over to LeetCode and actually solve this with some code. So over here on Java, we're going to go ahead and start out with int left equal to 0, and int right is equal to numbers.length minus 1. Then we'll go ahead and start a while loop. So while numbers of left plus numbers of right is not equal to target, we're going to continue this loop until we found the target value that we're looking for. We're going to go ahead and start our mid value for each iteration. So int mid is going to be equal to left plus right divided by 2. Like I mentioned previously, with the integer division, it's going to basically round up. So we're going to try to find the relative middle point of this entire array. Then we want to check if numbers of left plus numbers of right is greater than target. If this is the case, we want to go ahead and check to see if numbers of left plus numbers of mid is greater than or equal to target. If our left plus mid value is way too large, we need to go ahead and set right equal to mid. Otherwise, if we're just slightly larger, we need to go ahead and say right minus minus. Then outside that for loop, we're going to check else. So if the numbers left plus right is actually less than, now we're going to go ahead and check to see if numbers mid plus numbers right is less than or equal to target. So if the mid value and the right value is way too small, we're going to go ahead and set left equal to mid. Again, this works because the largest numbers are to the right. Otherwise, we want to go ahead and say left plus plus. We just need to minorly tweak a couple things. And then we're going to continue doing this logic until we found the target value, which we can go ahead and return a new integer array. And this is going to be left plus 1 and right plus 1. Now let me go ahead and comb through my code to make sure I didn't typo anything. If I did typo, I don't see anything, and I also forgot to log in, so give me a moment. All right, now we should be able to submit, and let's see if I typoed anything. And I did. Where am I missing a curly brace? Try to fix this. So maybe the while or the return was in the wrong spot. And there we have it. As long as I don't typo, this is a 0 millisecond runtime. It beats 100%. We weren't really messing around memory. If we wanted to tweak it, we probably could. But as always, if you guys did find this helpful or a little bit of value, make sure to leave a like, comment, and subscribe. I'm making videos like this literally every single week. As always, my name is Ethan Encoder. I hope you all have a great day, and I'll see you guys in the next video.